Okay, if you have not watched the first part of this, please go back to that because I need you to cut out the vocabulary and get it in your notes before you can do this section. So what we're talking about is we're talking about transversals and parallel lines. So what that means is that we're talking about a set of parallel lines, okay, and a transversal that cuts through them. So that basically means a line that cuts through them. Okay, we're going to look at all the definitions that you've cut out and glued in your notebook. So for instance, corresponding angles, same side interior, alternate exterior. Okay. So, and I've kind of color-coded them because I think for me it really helps to see the color coding. Alright, so for corresponding angles, these ones are a little bit interesting and you have to be able to visualize them. If you can't visualize, they don't really make sense. But for instance, this angle right here, this angle, right? We can actually slide that angle around and it's going to match up with other angles. If you visualize physically taking that angle and sliding it along this transversal, it is going to end up right here. Hold on. Okay. So that would be corresponding angles. When you can physically take that angle and slide it along the transversal and you come along another angle that looks the exact same. Those would be corresponding. Another example of corresponding, right? So if I take this off, we're not talking about these angles anymore. I'm going to give a different example. All right, this angle right here would be corresponding. And it corresponds, if we take this angle and we slide it up, it matches right up here. So it corresponds with that angle right there. So I'm going to go ahead and leave our blue in there. I'm going to color it in a little bit so we can see that those two are corresponding angles. Alright, so same side interior angles. So interior means inside of the parallel lines, exterior means outside. So interior means inside parallel, exterior means outside. So same side interior would mean that we need to be inside of the parallel lines and on the same side of the transversal. So here and here. Now you'll notice that one of these angles is obtuse and one of them is acute. So we start getting into exactly what it means to be same side interior. And what it does mean is that it's supplementary, which means that those two angles add up to 180 degrees. Okay, so this angle plus this angle must add up to 180 degrees. For corresponding angles, let's look back at those. These blue ones right here. Those are both acute, and notice they're the same angle, right? The same angle, just at a different part of the graph. So these are actually equal in size, equal in degree, equivalent, however you need to think of it. Alright, so alternate interior. Remember, interior means that we're inside of the parallel lines, and we're going to go alternate interior. So that's going to mean, if we take this angle right here, that is in, if we go alternate, so on the other side of the transversal, right here, so we're talking about those two angles, those are both acute angles, and it turns out that they're actually equal or the exact same size. So that was alternate interior angles. Okay. The last one is alternate exterior, and I'm hoping that we can kind of guess on this one, right? Guess what it might be. But if this angle is an exterior angle because it is outside of the parallel lines, right? We have interior inside, exterior outside. And if we want to go alternate, it needs to be alternate of it. You'll notice that these are both obtuse angles, and it actually turns out that both of these are equal. So notice that if they are on the alternate sides, or if they are on the alternate sides, they are equal. They are equal. Okay? Alright. So that's just kind of a diagram. For me, it really helps to start looking at the colors and look at this diagram. So let's see if we can make it useful for us. So given this parallel lines with a transversal, let's see if we can do some work. So let's say we know that this is 120 degrees. Let's see what we can do with that. Well, let's use our new vocabulary rather than vertical angles or anything else. So corresponding angles. So I'm going to notice that this angle right here can slide down and match up right there. So that means that this angle must be 120 degrees. Okay? So let's look at this. We have an exterior angle. So let's look at alternate exterior. So that means here to here. Alternate exterior. Those must be equal, that's what it says right here. So I'm going to get 120 degrees right there. So it's corresponding. So I'm just going to write it in the colors of the vocab that we use. Okay, so we got some stuff so far. Let's see, let's try to see if we could use alternate interior. So we have this interior angle, and if we use alternate interior, those two angles are going to be the exact same, which means that this is going to be 120 degrees. Notice, these are vertical angles, They're the same size, right? And that's how they should be. Okay, the very last thing is we're going to look at, the last vocabulary that we haven't looked at yet, is same side interior. So if we look at these interior angles, but we're looking at the same side of the transversal. So that would be this one and this one. Okay, so this is, we know they need to add up to 180. So if this is 120, this one's going to be 60 degrees, so that those two add up to 180. Okay, also notice that these two angles right here are what we call supplementary, and they should add up to 180 as well. Okay. You can use a lot of different vocab to fill the rest in, so I'm going to go a little bit quicker through it. But if we use some more corresponding angles, that's my favorite one to use. This 60 degrees right here can slide right down to right here, which means that we get 60 degrees right there. Okay, if I use alternate exterior theory, I know 60 degrees. These must be the exact same, so this must be 60 degrees. Okay, and then the last one I'll use is alternate interior. So my interior angles, these two, alternate, should be the same size. So I should get a 60 degrees right there. Alright, so that was using all of our vocabulary and how to find these angles. Let's see if you guys can do it on your own though. So let me give you this here, and I'm going to say that this is 30, so it looks a little more than 30, so let's say it's 55 degrees. Okay, you should be able to find the rest of these angles just given that 55 degrees. So I'd like you to try that out on the left-hand side of your journal and see what you can come up with. Alright, so we only have three more problems we're going to do. The third get a little bit more complex, right? So it's the same sort of diagram that we've seen. Okay, you should have already done this, the 55 degrees. It's the same sort of diagram that you see. So let's put right here, this one's going to be x plus 40, and this one's going to be 2x minus 22. So the first thing you have to figure out is what vocab word do these two correspond to? Because our instructions are we're trying to find x, right? So we need to be able to tell that these are exterior angles and they are alternate. So alternate exterior angles must be equal, which means that we can take this x plus 40 and set it equal to this 2x minus 22. And when we do that and solve for that, we're going to subtract x. 40 equals x plus 22 minus 22. And we get x is equal to 18. So that would be if we were trying to find x. Now what if I asked you, I want you to figure out what each angle here is. Okay, well we know that x is 18, so let's figure out what this angle is. Well, it's 40 plus 18, which is 58. This one here, if we plug in 18, we should get the exact same thing. Which we don't. 2 times, okay, that's why. Good thing I'm checking myself because I got the answer wrong. If we set this equal, this should still be subtraction, which means that we're going to add to both sides, which means that we get x is equal to 62. Completely my fault. So when we plug a 62 into here, we get 62 plus 40 is 102. And when we plug 62 into here, we also get that 102 degrees. And we should be able to solve the rest from here. You notice that, well, let's just go from there. So you can use all these definitions and you'd end up getting 102, 102, and you should get 78, 78, 78, and 78. Okay? Great. So I'm going to have you try one on your own, similar to this, and you're going to be solving for an x and a y. Alright. So here we go. This is the last one you're going to do for this section, and you're doing it on the left-hand side. So go ahead and find x, and then I'd also like you to solve for all angles. So 1 and 2. Okay, so go ahead and complete this on your left-hand side, and once you've done that, you have completed this whole video, and you can get started on the homework. So let me go ahead and put the homework up as you guys are working on this. Okay, here is one of your homeworks for the last section, and your other homework for this section is going to be okay, there's your homework for these two sections. So once you've completed this practice problem, you can work on those homeworks.